I'm going to kind of walk through these step by step, putting out each piece. I know there's a lot up here to try and follow. One, this should say GCF equals 1, not no GCF, so ignore that part. Because the GCF is 1, multiply 4 and -5 to get -20. Find two numbers that multiply to be -20 but add to be -19. Those numbers would be -20 and +1. Just put this off to the side. So from there we can rewrite our trinomial into a polynomial. Split it down the middle. It doesn't matter how you wrote this. If you did it the other way, we should still come out with the same answers. 4x was the GCF of the first two. 1 was the GCF of the second two. X minus 5 was the inside. So x minus 5, 4x plus 1 was our final answer for number 1. Do you have any questions on that one? Remember that if you are missing something or can't see something, all of this is on Canvas. Number 2, again, this should be GCF equals 1. Multiply 6 and 2 to get 12. Find two numbers that add or multiply to be 12, but add to be 7. Once you do this enough, you start to recognize that some of the numbers, oh, I've done that before, or I know that's 3 and 4, or they come a little easier to you. Rewrite your polynomial. 3k and 2 were what you could factor out, leaving 2k plus 1. So 2k plus 1 and 3k plus 2 were your factors. Did we get that one? Any questions on that one? Number 3 was another GCF equals 1. Multiply 8 and -3 to get -24. And you need two numbers that multiply to be -24, but add or subtract to be -10. The two that work were -12 and +2. So if you put those in, 4y and +1 were our GCFs, leaving 2y minus 3. So 2y minus 3 and 4y plus 1 were our factors for that one. Did you get that one? Do you have questions on that one? Beautiful. And 5, 7, and 9. So again, ignore that it says no GCF. That should be GCF equals 1 for number 5. Multiply 10 and -2 to get -20. So you're looking for two numbers that multiply to be -20, but add or subtract to be -1. So those numbers had to have been close together. So -5 and +4 work. Putting that in, 5p and +2 were your GCFs, leaving 2p minus 1. So your two factors were 5p plus 2 and 2p minus 1. Questions on that one? You put that one. Number 7, GCF equals 1. 4 times 1 equals 4. We're looking for two numbers that equal or multiply to be 4, but add to be negative 4. So you had a limited amount of factors there, but negative 2 and negative 2 work. So if you put those in, 2a and negative 1 were your GCFs, leaving 2a minus 1. So your factors were 2a minus 1, and then again 2a minus 1. So if you wanted to condense that, you could put 2a minus 1 all squared. You don't need to put this part. You could leave it just like this. That's fine. Remember that you shouldn't just be writing these down because that doesn't show you or tell you how to do it. You do need to be practicing this because that's the only way you get better at it. Number 9 also had a GCF of 1. Multiply 6 and 12. I really want to. So 6 and negative 12 to get negative 72. And you're looking for two numbers that add or subtract to be 1. Those numbers have to be close together. So negative 8 and positive 9 work. Put those in, and your GCFs were 2x and positive 3, leaving 3x minus 4. So your two factors were 2x plus 3 and 3x minus 4. What questions do we have on any of these? On that same page, you guys have problems with, let's say, multi-step factoring. We're going to do a few of those. Yeah. Yeah. For number 1, do we have a GCF? Is there something these all have in common? What is this? 10 divided by 2 is at the highest. We can divide all of them by 4. And I think that's the highest because that would be 5. So if you divide everything by 4, what would be left? 5n squared minus 26 and 52 divided by 4 is 26. 13. That seems to be too high. And then minus 6. Now on the inside, it is simplified a bit, and we can move forward with that same process. Take 5 and negative 6 and multiply those together to get negative 30. So we're looking for two numbers that multiply to be negative 30, but subtract or add to be negative 13. Negative 15 and 2. So So rewriting this, make sure you keep bringing down your GCF. Don't lose that, otherwise we lose part of the answer. So I'm going to rewrite this 5n squared minus 15n plus 2n minus 6. From there, I can do my grouping. Keep bringing down your GCF. What can I divide out of the first two? What did those first two have in common? 5. Is that the only thing? Five is definitely one of them. And. If we divide both by 5 and n, what's left? Negative 3. And then what could we divide out of the last two? 2. Positive 2. Leaving your n minus 3. Keep bringing down your GCF. And now we can write our two factors, which are what and what? 5n plus 2 and n minus 3. So technically we have three factors now because of the GCF. But if I didn't have that 4, if I multiplied everything back out, I'd get something different than what I need. So make sure you do not lose that. So the process is more or less the same. There's just an extra step now. Do we have questions on that process? Anything that makes sense? Confused about any of that before we continue? Let's do number 11. Does this have a GCF?
5.
5. So if I'm dividing everything by 5, what's left? 2k. 2k squared plus 15k plus 7. From there, the inside is a trinomial that has an a value other than 1. So we're looking for two numbers that multiply to be 14, but add to be 15. What would those two numbers be? And 1 times what would give us 14?
Oh, 114.
Okay, so bring down your GCF. Rewrite this 2k squared plus, I'm going to change the order of this so that it's 14k plus k plus 7. And then I can factor by grouping. Bring my 5 down. What could we divide out of the first two? 2 and K. And that would leave K plus 7. And then what can we divide out of the last two? 1. Remember, if there's nothing, 1 is always an option. And then we can write our 2 factors, or our 3 factors. KCF, and what are the other 2?
2K plus 1.
2K plus 1, and K plus 7. We're going to do one more, then I'm going to let you try the other 3. We'll go over those 3 tomorrow, but you'll have the remainder of class to work through those 3 after we do 12. Okay. KCF of 12. 2. When we divide everything by 2, what's left?
6.
6x squared.
1x
Plus 1x
minus 1.
minus 1. Okay. Now we need to multiply 6 and 1, or 6 and negative 1. So we need 2 numbers that multiply to be negative 6, but add to be positive 1. 3 and negative 2. Positive 3, negative 2. Here we have 6x squared plus 3x minus 2x minus 1. Then we could start by grouping. Do you have a question? What could we factor out of the first 2? 3. Is that the only thing? 3x. What would be left? 2x. One. And then what could we divide out of the last 2? Negative 1. Leaving positive 2x plus 1. And then bring down your DCF. What would your other 2 factors be? 3x minus 1 and 2x plus 1. We didn't, for sake of time, go back and distribute out everything, but those should work. Okay. I know we don't have a whole lot of time, but for the last 10 minutes, I want you to try these 3. And let me know if you have any questions.